Find the complete integral of px plus qy equal to pq using the Charpit's method. First, we need to write this given equation in the format f is equal to px plus qy. Let me take this pq to the other side. Minus pq. And now we need to get all these values fx, fy, fz, fp, fq. What is fx? Derivating f with respect to x. We get p. Fy derivating f with respect to y, that is q. Derivating f with respect to z, there is no z in this, so it is 0. Derivating f with respect to p, we get x. Derivating f with respect to q, we get y. And now using all these values in the Charpit's auxiliary equations. These equations are very easy to remember. Dx by fp equal to dy by fq. Then dz divided by p times fp plus q times fq. That is equal to dp divided by negative of fx plus p multiplied with fz. Here I am having p, so p is multiplied with fz. Further we have dq divided by negative of fy plus q multiplied with fz. I am having q over here, so multiply q with fz. Now when putting all these values, we get dx divided by fp, that is p. So it is dx divided by p equals to dy divided by fq, that is q. Then dz divided by p into fp. fp is x and fq is y. So writing here x, it is px plus q into fq, and fq is y, equals to dp divided by negative of fx. fx is again p. So it is p plus p multiplied with fz. Because there is no z, fz is 0. So we have negative p only over here. And then dq divided by negative of fy. fy is q. Plus q times fz. fz is 0. So it is negative q only. And now I am going to choose a ratio so that I can get the value of p and q. So let me choose the last two ratios. Cancelling this negative sign and then integrating both the sides. On integrating we get, it is log of p equals to log of q plus the constant log of c, where log of c is constant. Log of p equals to log of qc, or p is equal to q into c. So this is the value of p I am getting in terms of q, but I still need the value of q. Let's check what equation is given to us. I'm having this to be the given equation, px plus qy equal to pq, and I'm having the value of p to be q into c. So I'm going to put this value in this equation to get the value of q. So it is q into cx plus q into y equals to q into c into q. Or we can have cx plus y equal to cq. Right? Cancelling q all over. So q is equal to cx plus y divided by c. Here q is non-zero we have taken. So we have got the value of q to be in terms of xy. Also I need to get the value of p in terms of xy. Also I need to get the value of p in terms of xy. So let's put this value of q in this. So p is equal to q into c. The value of q we have just found to be cx plus y divided by c. Cx plus y divided by c into c. Cancelling this constant. and we get the value of p to be cx plus y. So we have got the values of p and q to be in terms of x, y, right? And now we need to use the equation, third step, dz equal to p dx plus q dy, because I need to get the value of z. For complete integral, I need to get the value of z. In the given equation, there is no z. In this given equation, there is no z. So we cannot get the value of z straight away from this given equation by putting the values of p and q. To get the value of z, I need to use the equation dz equal to p dx plus q dy. In the previous example, I am already having the given equation to be z equal to pq. In the previous example, in the previous content. So I just straight away put the values of p and q in this given equation and get the complete integral to be z equal to whatever it was. But here I am not having z in the given equation, therefore I am going to use this equation now. What is p? It is cx plus y dx plus q is cx plus y divided by c. Cx plus y into c dx plus cx plus y dy whole divided by c, and I am going to take this c to the other side. So this is c dz equals to cx plus y into c dx plus cx plus y into dy. So on the right hand side, let's take cx plus y common and we get c dx plus dy. We can also write this as the derivative of cx plus y. Can I write like this? When taking the derivative, we get c dx plus dy. We are getting back this. So I can write this as derivative of cx plus y. And now when integrating both the sides, we get cz equal to, because this is same, you can also use the substitution method. You can put cx plus y equal to t, and then d of cx plus y will be equal to dt. So you will get the integration of t dt. And when integrating this, we get t square by 2 plus the constant a, let's say, where a is a constant. And now putting back the value of t over here, we get cx plus y whole square divided by 2 plus a. So this is the complete integral of the given equation. We have got the value of z in terms of x, y, where a and c being the constants. Right? So this is how we solve the differential equations by using the Charpit's method. In the next content, we are going to solve some more examples. Okay, thank you. Stay blessed.